Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Last session we have seen about the conversions of binary, decimal, octal and hexadecimal numbers, right? And in this session we are going to see about binary representation for signed numbers. Okay, we'll see what is signed numbers and what is the binary representation of signed numbers in this session. I think you are clear with the conversions, that is binary to decimal conversion, decimal to binary conversion, and octal hexadecimal conversions from binary and to decimals and all. Everything binary, decimal, octal, and hexadecimal, you are clear with it, right? If you have any doubts, you can ask me. I'll explain it again and make sure you do these workshops and you just find the answers and send it to me. Okay? And now we are going to see about the binary representation for signed numbers. Okay, computer will handle both positive and negative numbers. Signed numbers means we are referring to the negative numbers only. Okay, the simplest method to represent a negative binary number is, we'll say it as signed magnitude. Okay, negative is signed and positive is unsigned. If you are mentioning a negative binary number, we'll say it as signed magnitude. Okay, in the signed magnitude method, the leftmost bit is the most significant bit, that is MSB. That is called the sign bit or parity bit. Okay, this in the signed magnitude method, the leftmost bit we'll say it as MSB, that is most significant bit, and that is called the sign bit or parity bit. Okay, the number or these numbers are represented in computer in many ways. This signed magnitude representations one's complement and two's complement. Okay, first we'll see what is signed magnitude representation. Signed magnitude representation. From the word itself we can say, if a whole number is determined by the sign used before it, it is signed magnitude representation. Okay, if it has a plus sign or if it has no sign means we know it is a positive. If it has a minus sign, it is considered as a negative one, right? For example, if you see plus 43 or simply 43 means it is a positive number, and if you have minus 43 or minus 35 means these are the negative numbers. Okay, in the signed binary representation, the leftmost bit will be considered as the sign bit. Okay, if this bit is 0, that is a positive number, and if it is 1, it is a negative number. So here the signed binary number has 8 bits. That means only 7 bits are used for storing the values, that is the magnitude, and 1 bit is used to store sign. That means here we'll consider plus 43. Okay, plus 43. Now let's see the memory for 43. We have 0, 0, 1, 0, 1, 0, 1, 1 means the leftmost bit is the most significant bit or the sign bit. Okay, here we have 0. So that 0 will represent that the number is positive. Okay, and the rightmost bit is the LSB, that is least significant bit. Right, so this is the magnitude or the value. Okay, if there is minus 43 means the memory will be represented as 1 1 0 1 0 1 0 1 means the first number is 1. So the 1 is the sign bit or the most significant bit here. 1 represents that the number is negative. Okay, and the right corner number is LSB, that is least significant bit, and this is the magnitude or the value. Okay, so you know what is signed magnitude representation. Okay, the whole number will be determined by the sign which is used before the number. Okay, so here if plus is there before the number or if no sign is there, we'll consider it as a positive number. If minus is there before the number, we'll consider it as negative number. Okay, next let's see what is one's complement representation. Okay, this is a easier approach to represent the signed numbers. That means here for a negative number, that is only the number whose MSB is 1, we have to follow some of the steps. We have to convert the given number into binary. We'll be having the decimal number, right? We'll convert the decimal number to binary, and then we'll check if the binary number has 8 bits, right? If it is having only 6 or 5 or 7 bits, you have to add 0 at the leftmost bit. Okay, so it has 8 bits, right? So we have to make it as a 8 bit. Okay, if it has less, we can add 0 to the leftmost bit and we can make it as 8. Okay, and then we will invert all bits. That means invert means zeros and all you will put as 1, and 1 and all you will mention as 0. That means if value is 1 0 0 0 means you will convert it as 0 1 1 1. Understood? The value whichever is 0, you will convert it to 1, and wherever 1 is there, you will convert it to 0. That is 1's complement. Okay, first we'll see an example. First we'll consider the decimal number, and you will convert the decimal number into binary number, right? After converting it into binary number, 1's complement means you will just convert the zeros to 1 and you will convert the 1 to 0. That is invert all bits. Okay, this is the easier approach to represent the signed numbers. This is used for negative numbers only. That means the number whose MSB is 1. Okay, this is 1's complement. Okay, are you clear? Next we are going to see about 2's complement representation. Okay, 2's complement method means that is for negative number. Means first you have to invert all the bits in the binary sequence. That is, invert means we saw it already. You have to change every 0 to 1 and every 1 to 0. That is, first you are doing the 1's complement there, and then you will add 1 to the result to the LSB, that is least significant bit. Understood? First, in 2's complement, first you will do the 1's complement. If it is a negative number only, you will do this. First, you will invert all. That is, you are finding the 1's complement, and then you are adding 1 to the result to the LSB, that is least significant bit. Okay, understood? Let's see an example for this 2's complement representation. 2's complement representation for minus 24. 24 is a decimal number and we are having a negative value. Minus is there, right? So the binary equivalent for 24 is 11000. First you have to find the binary equivalent for the decimal value, and then you have to write it as a 8-bit format. Here you are having 11000. So you are having only 5 bits, right? So you can add 3 zeros to the left side and you will change it as a 8-bit format. Okay, and then you will find the 1's complement. 1's complement means you will invert everything. Zeros and all you will write as 1, and 1 and all you will write as 0. So 000111000 means when you are finding the 1's complement, it will change to 111000111, right? And then you will add 1 to the LSB, that is the least significant bit. Okay, so at last here in this 111000111, here if you are adding 1, what you will get? See, at last digit will be 0. The previous digit also will be 0. It will become 10. So 0 down and 1 will be carrier, right? So the answer will be 111010000, right? I think you are clear with 1's complement and 2's complement. If you are having doubt or if you are not clear, you can just ask me. I'll just explain it again. Okay, I'll just repeat it once. Signed magnitude representation. Signed magnitude representation means if the whole number has a sign before that number, we'll consider it as a signed magnitude representation. Okay, if a number does not has any sign, or if a number has plus, it is a positive number. If a number has minus before it, it is a negative number. Okay, here it will be represented with 8 bits, and if the first bit is 0, it is a positive number, and for a negative number the first bit will be 1. Okay, Then let's see the ones complement representation. Ones complement representation means first step is if it is a negative number only. Okay, this is for a negative number only. First you will convert the decimal number to binary number, and then you will make it to a 8-bit number. That means if you are having the value for 5-bit or 4-bit means you will add zeros to the left side and you will make it as a 8-bit. Alright, and then ones complement means you will invert all the bits. That is, you will change 1 to 0 and you will change 0 to 1. Understood? Choose complement means first you will do the ones complement only. That means first you will be inverting all the bits. That means if you are having a decimal number, first you will find the binary value for that particular decimal number and you will make it as a 8-bit number. How you will make it as a 8-bit number? You will add 0 to the leftmost bit, right? Least significant bit you will add 0 to the left side and you will make it as a 8-bit number and you will do the ones complement. Ones complement means you will invert all the bits in that binary sequence. That means you will change every 0 to 1 and every 1 to 0. That is ones complement. After that, after finding ones complement, you will add 1 to it. Okay? You will add 1 to the least significant bit. Okay? Least significant bit, if you are adding 1, you will get a value that is the choose complement of that particular decimal number. Right? Think you are clear with this binary representation for signed numbers. That is, today we saw signed magnitude representation, ones complement and choose complement, right? Next session we will see the binary arithmetics and all. Before moving on to the binary arithmetics, be clear with this ones complement, choose complement and signed magnitude representation. Okay, you will get questions in 2 marks, 3 marks and even 5 marks also to find the ones complement and choose complement. Okay, only if it is a negative number you can find this complement and all. They would have given the positive number and they'll ask you to find out the ones complement and twos complement also. Last year also we got a question like that. That means you have that your answer must be this, since this is a positive number we cannot find the complement of this number. Like that you have to write, right? If it is a positive number, don't find out the ones complement, twos complement and all. Okay, thank you for your valuable time. Stay home, stay safe, take care, bye.